What's up, everybody? This is Kaleb with HVAC School, and I am here with Hunter Collins, Kalos Services. We both work at Kalos, and we're going to do a quick video to test out the BLUON Tech Support that you can get through the app. If you have been accredited, you have access to the app and the entire library of systems and of manuals and conversions and stuff like that that they have through the app, and along with all of the training information that they have. But they also have a tech support line that you can call 24/7, and what we're going to do is we have 3 sample calls that we're going to use to call and just kind of gauge the waters as far as the quality of the tech support that we're going to get from BLUON. I'm assuming we're going to get different guys every time. These guys do not have the questions ahead of time, so it's an organic call, and this is right here the BLUON Tech Support Line. So here we go. All right, so our first call is going to be regarding a humidity issue. This was a call that we experienced in Wilmington, North Carolina. It was a Goodman system. It was a 3.5 ton unit, which was already a little oversized for the space that he was inhabiting. The airflow, apparently at some point, a technician came over and replaced the blower motor in the air handler in the attic, and it was a larger blower than what it came with from the factory. So the setting was on high. They did a flow hood test, I believe, and they got about 1600 CFM, total system CFM. And so the humidity was super high, obviously, for obvious reasons. The coil was running warm, it was short cycling, and it was already oversized, so it was just exasperating the issue. What we ended up doing was that they lowered the fan speed. We got down to like an 1100 CFM, total system airflow, and that corrected the issue. It hasn't solved the oversized problem, but that is ultimately what we had an issue with. Was our delta T was a little off. Once we lowered that fan speed, we got that humidity down a lot.
BLUON Tech Support, this is Nathan.
Hey Nathan, this is Hunter with Kalos Services.
Hey Hunter, how are you?
Good, how are you doing?
Not too bad, man. What can I help you with?
I got a system here. We've been having some humidity issues. Getting about a reading about 62% humidity inside the home. Everything else checks out, the pressures are good. My delta T, everything else checks out just fine.
Not yet. Have you checked your fan setting?
Yes.
See what your fan speed is?
Yes.
What is your fan speed?
Set to high.
Set to high. I would take that. Where are you located?
In Wilmington, North Carolina. And the airflow is we're getting about 1600 right now, CFM.
What size system you working on?
The 3.5 ton.
3.5 ton?
Mm-hmm.
So yeah, 1600, 3.5 ton. So if you're in a high humidity area, I definitely suggest lowering that fan speed down in order to get a little slower airflow. It's going to help take that humidity out. It's going to cool your coil down a lot more and get the humidity out a lot better than running that high. So typically like to see about 350 CFM per ton in a high humidity area. I'm located down here in South Florida, and that's where I got mine dialed into.
Oh, I hear you.
Right about 350.
I hear you. Also the duct is sweating pretty good amount too.
The duct's sweating. So
yeah.
Where at? Like in the attic or where at?
Yeah, in the attic.
Yeah. So that could be. You need to make sure it's well insulated, and also you don't have any leaks in there. Like seal that ductwork up.
Okay.
So I would check for leaks in the duct, and make sure that you're insulated well. Is it duct board or metal duct?
It's duct board.
Duct board
with flex.
You probably
yeah.
got some leaks. Yeah, you probably got some leaks going on in there. So I would definitely feel around to see where you have some leaks.
Okay.
See if you got leaks, and seal that up with some mastic.
Okay.
Cool. Anything else you got for me?
Nope. I think that'll be it. I appreciate it.
Cool, man. All right. Yep. No problem.
Thank you.
Thanks, man.
All right. Bye-bye.
Yep. Bye.
Okay, so this second call, this is going to be regarding a low voltage short. It is blowing the fuse, so let's say we've got a 3 amp fuse on a circuit, on a low voltage circuit, and we are we're amping out high on the yellow wire, so the contactor wire going to the contactor. The contactor is not actually ever pulling in, it's just tripping automatically. But without a call, it's perfectly fine. We've visually inspected everything. Nothing seems off, no loose connections. Everything is good. Immediately blows the fuse as soon as we reset that and we get a call for cooling or for heating. We've tested all the other components. We know that we've narrowed it down to the Y circuit, and just spoiler alert, the issue here is we have a shunted contactor coil. So basically, if you ohmed out that contactor coil, you would read really, really, really low resistance. What happens is doesn't have enough resistance, so the amperage goes up and you end up with a blown fuse. You have to keep in mind that just ohming out a regular contactor without reference to a good contactor, that can be problematic, because then you don't know what it should read to begin with, and it's an inductive load, so it's going to change with the occurrence of reactive power. If it's reading really, really low resistance to begin with, then you're not even going to be able to make it to the closed contactor. It's going to completely blow the fuse because of overamping. And that's what we are discovering here on this particular call. The guy that we're about to call has absolutely no idea about this issue, so we're going to kind of test his knowledge on low voltage circuits and troubleshooting a low voltage short. Here we go.
Hey, Mike. This is Hunter with Kaleb Services. Good. How are you doing?
How you doing?
Good. How are you?
I'm doing great. I'm doing great.
Awesome, man. I'm at this system, and for some reason, the low voltage fuse, which is a 3 amp fuse, keeps blowing. Checked all my wiring. I don't see any rub outs. Nothing's touching. Everything looks good to me. I'm just kind of...
We're blowing the fuse for a reason.
Right.
What components are tied into it?
I have my pan switch and my secondary float switch.
It's just the 2 switches?
2 switches, yes.
Okay. One thing we could do is we could put an ohm meter on each of the switches individually to see if there's a high resistance on the switches, or we could turn around and take each one of them out of the circuit one at a time. We're going to lose a fuse or two that way, but...
Yeah. No, I've actually already taken the switches out one at a time, isolated them. It's just a normal. It's a heat pump, so I've got the reversing valve and just going to the thermostat like normal.
Okay. So you've got the reversing valve in there, the reversing valve relay in there. Anything with the thermostat? Have you checked the wiring at the thermostat to make sure that there's nothing shorted in there?
Yes, I have.
So you've ohmed out all your wiring and everything.
Yeah.
About the best we can do is to go through and check everything one at a time, because it's either got to be wiring or it's got to be one of the devices that's pulling an excessive current when it tries to engage.
Okay. What about the? Do you think I should check the amperage on each wire?
Well, you could put depending upon what kind of a meter you're using, you can use a fluke that'll go up to 10 amps.
I'm just using the regular compact filled piece, but it has an amp clamp on it. So.
Okay. It's just 3 amps kind of far down on the scale, so it may be a little hard to catch it.
Okay.
Have you made sure that there are no loose connections on any of the commons or anything like that?
Yeah.
24 volts?
Yes, this is a 24 volt application. Yeah, I've made sure everything's tight. Like I said, no skint wires, nothing's rubbing or anything.
Is there one of the secondary wires that goes to ground off the transformer?
No.
Okay, so we got a floating secondary.
That was going to be my next step, was to check the amperage.
How many fuses have you put in?
2.
Okay, so chances are at you're actually seeing that kind of an amperage. You can check it, but if it's popping them relatively quickly, it's gonna go quick. If you've got a max capture on the meter, you can use that. It'll show you where it actually blows at. But it sounds like we've got a short, or is it blowing the fuse with pulling in like a contactor or anything like that?
Well, I just checked the amperage on the all the wires, and on my yellow wire, I actually got around 6 amps.
You got 6 amps on the yellow wire.
Yep.
So that's most likely going to be going to your compressor contactor.
Right.
So I just want to clarify one thing real quick. What we did, Mike was right. Using a compact meter like your regular multimeter, trying to amp out one of the wires, if you've got an immediate fuse blowing, that's not going to really do much good, because it's going to blow so quickly. You're not going to really be able to read whatever minimal amps you're going to get. It might be too quick. So what we should have done was told Mike that what we did was we came to the thermostat, we put a little popper or some sort of resettable fuse inside the air handler, and we disengaged each individual wire and jumpered each one individually to red, and then until we finally got the fuse to reset or to blow. So that would have been a much better way and more practical way in the field to be able to isolate which circuit has the short. And of course, if we did this and we had the issue that we were talking about, a shunted coil, as soon as we jumpered yellow to red and then we reset power, that would immediately trip the fuse, and we would know that on this circuit, the Y circuit, is our issue. Just wanted to clarify that's something that we should have done. Mike from BLUON was absolutely correct in the way that he explained things. We were a little off in the way that we attacked the problem.
Have you look at your compressor contactor and see if you've got a contactor that's hanging up that isn't allowed to pull all the way in, they will pull excessive current on the coil.
Okay.
What happens is it doesn't let the contactor pull all the way in. area of the coil,
Mm-hmm.
and so it's holding way out, and so that will cause excessive current draw.
Okay.
So that's what I would look at. And in the case of a lot of those contactors, if they're not pulling in, you can sometimes open them up and clean them. But if it's pulling 6 amps, it's way over what it should be.
Right. Do you think maybe I should ohm the contactor out?
I don't think ohming is going to show you anything, because it's the magnetic field and not being able to pull the contactor in, pulling the really high current.
Okay, why is that?
Well, have you ever worked with a solenoid and plugged the solenoid in, put voltage through the solenoid without the solenoid on the solenoid valve?
Yes, I have.
What happened? You burn up the coil.
Yeah.
It's because it's looking for that magnetic.
Yeah.
So I would say that it's in that coil that's not being allowed to pull in all the way. So, I mean, I would look at the contactor mechanically. You can't ohm it.
Right, and what happens if it ohms pretty low though? Like I'm getting about at 1.5 ohms.
Well, you'd have to compare it to a good one to see what the good one is running.
Yeah,
Because,
I have a couple more on my van, and I compared them to that, and I'm getting about, so I got 1.5 on this one, but on those, the good ones, I'm getting around 7.5.
Well, if you've got that kind of a deviation, then I would say change the contactor, and you may have something, a turn-to-turn short inside the coil.
Okay, all right. Well, I appreciate it, Mike.
Not a problem.
All right, thank you, sir.
Have a great one. Thanks
You
for
do.
calling
You
us.
too. You have a great day.
All right. Bye-bye.
Bye-bye.
All right, so this third call is going to be specifically BLUON related. So a lot of their conversion, processes, they'll say, hey, replace the low pressure switch. Let's fine tune, so to speak, the metering device. Say if you got an adjustable TXV. But what I kind of want to do is pick their brain about why that is. We know that BLUON is operating at lower pressures, but specifically, what about low ambient cooling, things like that, things that I want to get kind of an idea more clearly why they've put these procedures in place for retrofitting processes. So we're going to call again, see what we can get, and kind of pick their brain a little bit about the BLUON process itself for retrofitting, and just generally speaking about the new bid tool that they have in the app. They just released this a couple of months ago, and you can actually see how many, on average, I'm assuming, how many hours that this particular retrofit's going to take, and how many pounds of the TDX20 refrigerant that this system is going to hold.
BLUON Tech Support, this is Brian.
Hey, what's up, Brian? It's Kaleb with Kaleb Services.
Hey, Kaleb, how you doing, man?
Good, man. How you doing? I've got I'm doing another BLUON retrofit over here. It's a package unit. It's an indoor style package unit.
Okay.
Yep.
All right.
It's just straight AC, air cooled, and I just had a couple of questions about specifically the low pressure switch and the metering device.
All right, cool.
Yeah.
So,
Go ahead.
well, my question was going to be, what machine are you working on? I understand it's an indoor floor mount, but
It's a carrier unit, 50 Bravo Victor Echo 020.
okay.
Yep.
All right, so it's an old carrier stand-up. Beautiful.
Yep. So I noticed the high pressure and the low pressure cutout. It looks like that they're standard, but why would I need to replace those to begin with on any system?
The low pressure switch would be because some of them use them as a pump down control, so they're set in the high 30s, and if you're still using the pump down, you'd be all right with a 35. But again, depending upon what you're running temperature wise, and that stand-up unit should not be affected. But you look at the cutout of the low pressure switch, if it's a pump down system or if it's borderline what you're going to be running with BLUON's pressures.
I gotcha. Okay.
And I would probably say 90% of the units that are out there, you don't actually have to change the low pressure switch, but you want to look at it to make sure that it's a fail-safe. Fail-safes typically trip at 26 pounds or less, whereas operating pressure controls, something that was going to be a pump down, will be higher than that, and you don't want to have false trips.
I gotcha. Yeah. Okay. So because the TDX20 is operating at lower operating pressures, you just don't want it to go off too soon, prematurely.
Yeah, because we run about a 10-pound. We run approximately 10-pound less suction than our 22, and then you also mentioned the high pressure safeties.
Yeah.
Typically, we don't have to change those ever because we're not going to have a problem tripping. If you lose air cooled, you lose a condenser fan motor, you're going to trip at 425, and we're perfectly safe with that. So the high pressure switches generally don't have to be messed with at all. It's when you get into the fan cycle controls where you're maintaining head pressure when you got low ambient conditions and the machine still needs to ask for cooling, and to be able to take full advantage of the energy savings, then you can just tune them down to shut off the fans at 200. Most of them have a 35 differential built into them. So you bring it down to 200-pound cutoff. That'll bring it back on at 235 instead of like 22 where you're maintaining more of a 250-pound head.
Okay.
Make sense?
Yeah. No, absolutely. So then what about these metering devices then? Because I've heard that there's a lot of adjustment or I guess, for lack of a better word, fine-tuning, so to speak, of these retrofits for BLUON. I'm looking at the...
On the machine,
Go ahead.
Yeah, on the machine that you mentioned, the Carrier 50 BV, that's going to have an adjustable expansion valve.
Okay.
And that will need to be adjusted. You kind of have to make up for the pressure difference between 22 and BLUON. So knowing going in that you're going to have to adjust the valve in 1 to 4 turn to be able to make up that pressure difference.
Now that's 1 to 4 turns closed, right?
Yeah, 1 to 4 turns closed. Yeah, if you're opening, there's something else going on with the system.
Right.
That'd be a flag. So yeah, it's 1 to 4 turns closed, tightening up the spring.
Okay.
So maybe that makes more sense by saying tightening up the springs, because you have to make up the 18-pound difference that you're seeing.
Yeah, no, that makes sense. Okay, yeah, interesting. So I'm looking at the retrofit and everything, and it appears as though that there's this thing in the app called Bid This Job. Now, I'm already here, but it says that, 14 hours labor, 17 pounds of refrigerant, which matches just pretty closely to the original factory charge. I'm assuming this is a new tool that's within the app?
Yes, we just added the Bid This Job portion of the app's probably 2 months old at most. And then we're also working on adding another one, FYI to you, that's going to be including all the parts. It's going to be pretty fantastic when we get done. So we're collecting more data. So for every piece of equipment we've got in the app, you're going to be able to order right from your local vendor through the app, which has nothing to do with us. You're going right to your vendor and ordering the parts. Either we'll call or deliver in some cases.
Oh, that's cool. So
yeah, it's gonna be pretty sweet. But going back to the Bid This Job, that is kind of a mid-range, give you an idea. If you're bidding the job, this is what it's like. You kind of have to look at the conditions, whether, is the machine easily accessible, or you're working off of a 20-foot ladder. So you see there's ranges. The refrigerant, the amount of refrigerant is going to be kind of based off of our rule of thumb of you end up at 90 or 95% of the original charge.
Oh, okay.
So when you're looking at the job, so if it's a really difficult job, you're going to want to go on the high end of the labor, or if it's walk right up to it and sitting on the ground next to your truck, you probably get away with the lower end.
Gotcha. Okay. Now that's still really helpful. That's awesome.
Well, we're trying, man. We want to make it as easy as possible for the mechanics that are out there. I mean, we kind of understand the headaches of it from doing it. Like, me, 40 years in the trade. We got Mikey and Nate and David and all these years sitting around right here at our own shop. So it's kind of cool to have these guys and be able to get guys off the job. And it's not just for conversions. The guys can call for any issues, any HVAC related issues.
What about design issues? Like you got an oversized piece of equipment, or you've got negative or negative pressure zoning and stuff like that. Call you guys for that too?
You know what? I've never turned down anybody's questions. So, yep. If I got to dig into the weeds a little deeper, I've been on calls with guys for 3 days at a shot, if you will. It's like 4-hour conversation here. Next day, go back. He's doing some more tuning. So yeah, we will actually take the time that they need, whatever their need is. So,
wow.
Design questions, I'll get into the books maybe I won't solve it in a 30-minute conversation and have to call back or set up more talks. But yeah, absolutely.
That's awesome, man. I appreciate the help.
No, it's my pleasure, man.
All right, man. Take care.
You do the same, Caleb.
All right, buddy.
Stay safe, brother. Be healthy.
All right, you too.